Hello, welcome to the New Stack Makers, a podcast where we talk about at-scale application development, deployment, and management.
Tigera, the inventor and maintainer of open source Calico, delivers Calico Cloud, the next generation cloud service for Kubernetes security and observability. Tigera and the New Stack are under common control.
Hey everyone, welcome to a new episode of the New Stack Makers. And today I'm so excited for Ratan Tipirneni to join us. Ratan is President and CEO of Tigera. Ratan, thank you so much for joining us today.
Oh, absolutely, Alex. Very excited to be here.
So our topic is cloud native application security, but I was looking at your background on LinkedIn and I saw that you started working at Sun in the 1990s. And that was kind of like the heyday of servers and the early incarnations of data centers. And applications were different then. We've seen the results of what those applications become over the past 5 to 10 years. I really think, with the relevance of the cloud native era. So I'm curious how you reflect on application security trends when thinking about your work at Sun as a senior product manager.
Yeah, no, that definitely takes me back a while. So first, I actually was part of the group that helped incubate Java. So while those were the days of servers, I've got to say, we were thinking ahead and we were preparing for the next couple of decades. And I've got to confess, when I think back about that group and that team, it was pretty amazing, the kind of talent and vision they had. Because literally everything we're seeing today in the market was envisioned by a set of very smart people there. So I feel very fortunate to have been in their midst, to have rubbed shoulders with them, because we had envisioned this notion of centralized computing and moving the power more to this central node and having the endpoints be fairly dumb so that you can access applications from anywhere. And while we talk about cloud native applications today, it's honestly a new name for something that existed that Sun pioneered. We were talking about the distributed application infrastructure. We built out the entire middleware stack to enable that. So a lot of what we're seeing today, honestly, came out of some really heads of some really smart people there. But in thinking back, I've got to say, while that group got most of the things right, there are a couple of areas in hindsight. If I could go reverse time and go back in time, there are probably a couple of things I would do differently. First is security. Candidly, there was very little talk about security in our meetings when we were trying to envision the future. We got everything right except security. Honestly, we never spoke about security because we had no idea that the problem was going to be so daunting to a point it was going to be a showstopper. Probably the most we spoke about was authentication, and that was about it, right? We never, ever envisioned that the problem would take a life of its own to a point where it would stop, progress in cloud-native applications. And the second thing I'd say is, one thing we did not get right in our vision was the personas, because we had imagined a future state of the world, but we didn't quite map out how the roles of the different personas would change. And if you think about it today, in the cloud-native world, the cloud DevOps engineer is, she's responsible for pretty much everything, right? Getting the applications into production, managing the applications. She's responsible for security. She's responsible for compliance. And we never thought about it that way, because if we did, we would have probably envisioned security more as code, and we would have modeled security for the developer. So we didn't really see these roles and personas changing. But then again, if you think back, like 2 decades back, that group got everything else right, and that I think is a stunning accomplishment.
That is a stunning accomplishment. You can't think of everything, right?
I guess so, yeah. You got 9 out of 10 things right.
So take us to today in Tigera. Tell us about Tigera for people who may not be familiar with it and its take on cloud native application security, the role of Calico, and the relevance of observability today?
Yeah, so Tigera is a leader in active cloud-native application security. So we have pioneered this architectural concept called active cloud-native security. And really the genesis of this is that we saw most of the first-generation cloud-native security application companies, their solutions, to give them credit, they did a tremendous job in moving the ball forward compared to the legacy firewall vendors who still are pushing box-based firewalls that work on the concept of static firewall rules based on IP addresses to protect the perimeter. So compared to that, the cloud-native security companies have done a great job moving the ball forward. However, in the last 2 to 3 years, as they've rolled out their solutions, their focus has been on vulnerability scanning, and they've taken an old architectural concept and tried to bring that into the new world. And the net result of that is not working. It is failing. We're seeing our customers struggle, and they're pleading for help. And so that's the reason, we stepped back and said, we need to take a fundamentally different approach to solving this problem. And that's when we launched the active cloud-native active security. So what is that? So that really simply is 3 pillars that defines the architecture for this. The first pillar really is around reducing the attack surface with zero trust. Again, the genesis of that is the number of software components and the number of vulnerabilities and malware and zero-day attacks is going through the roof. And so you have to build your security strategy on a foundation of zero trust so that you can just minimize your attack surface. And that has to be the foundation. And in the absence of that, we said, hey, you're really building your security strategy on quicksand. It's going to collapse. And that's what's happening with our customers. The second part is that this is an unbounded problem in terms of new threats coming in. So the new threats are both known and unknown threats, and you have to have a strategy to be able to address both types of threats. The known threats are relatively easier and straightforward, but the unknown threats take quite a bit of innovation to be able to handle because those are zero-day threats. And the third part is that even if you were to do everything right, you're still going to end up with some breaches. And at that point, you need a mechanism to automatically mitigate risk inside your environment so that you can keep your applications running while you go figure out long-term remediation solutions. So those are the 3 architectural building blocks for cloud-native application security, active cloud-native application security. And that is really what we have announced today.
Okay, so the Calico Cloud capabilities that you announced today, maybe you could go through those a little bit. I can sense from the overview what it covers, but is there anything in particular you'd like to point out that's important?
Sure, yeah. So let me maybe perhaps double click on the 3 building blocks I just talked about. So the first one really is I talked about reducing your attack surface with zero trust. And really there are 4 very powerful components that Calico Cloud provides to power the zero trust aspect of Calico Cloud. The first is anytime a microservice inside a Kubernetes cluster has to reach out to an external resource, let's say maybe it's an API like Twilio, or maybe it's reaching out to a SaaS application like Salesforce on the internet, or perhaps it's trying to get to like a cloud-native service like AWS RDS. Anytime you enable that microservice to access these external resources, it turns out the way Kubernetes is designed, everything inside the Kubernetes cluster then gets access to that. So that creates a huge risk around data exfiltration. So we have something called Zero Trust Workload Access that provides extremely fine-grained access to these external resources. The second part is we have a very powerful mechanism to implement microsegmentation. It's identity-aware microsegmentation for workloads, where you can isolate the workload so that even if something were compromised in your system, you can actually prevent lateral movement, which is a very effective way to implement a kill chain and prevent malware from spreading and taking over your system. So that's the second aspect of the zero trust. The third aspect is we've built a very creative mechanism to bridge to and integrate with firewalls, because the truth is firewalls are going to exist in the customer's infrastructure. And we provide a mechanism to integrate that without having to open up large site ranges in your firewall to talk to Kubernetes clusters. And the fourth is we've built an Envoy-based application-level security where you can take the concept of zero trust and microsegmentation and take it down to an extremely fine-grained level at specific function calls at the application level, and really only allow the communication that is absolutely necessary. So those are the four components as of the first pillar, zero trust. In terms of the second pillar, to detect known and unknown threats, there are four things we will do. First is we are the only solution in the market that can provide protection from both container and network-based threats. On the network side, let me start with that. We have built a very powerful workload-based WAF solution. And instead of putting a WAF, which is for really application protection at the edge in terms of ingress, we actually move it much closer to the workload, and that helps protect the workloads. And we have a very powerful purpose-built IDS and IPS, again, for the workloads with deep packet inspection, where we use some very powerful algorithms to detect attacks that are network-based. And then we have the ability to even crack open the packets and maybe compare them to some smart signatures to see if your system's under attack. And the third piece is we built a very powerful machine learning-based zero-day workload threat identification. This is where we've built some very, very powerful probes using our eBPF technology to monitor process-level data, file system access data, system call data. We use all those signals to give us an indicators of compromise to see if there's any anomalous behavior across those three vectors, through which we conclude that perhaps your system is under threat and we can take some corrective action. The last thing is we have a mechanism to constantly look at runtime for vulnerabilities and known malware out there. So this could be in the form of binary files that of malicious attacks, or it could be known bad IP addresses or known bad networks. We look at all that stuff and are constantly monitoring your system to prevent known and unknown threats. And the third pillar really is around risk mitigation. And this is where what we do is we automatically able to map out your entire Kubernetes system. Kubernetes, as you're aware, is quite complex. It has a lot of abstractions. It has namespaces, it has services, it has pods, it has replica sets. So when you have an attack, a vulnerability, or a malware, to understand how that fits into the context of a Kubernetes system can be very difficult. So dynamic service and threat graph is a very powerful ontology that shows you the various elements in the Kubernetes system, the relationship to each other, and where the threats are manifesting. And then we also provide a security policy recommender where once a threat's been identified, you press a button and you can automatically either isolate it or protect other parts of your critical infrastructure or services. And then we have an admission controller that serves as a filter to make sure it only promotes images that are clean into production. And finally, if anything looks out of the ordinary, we provide our customers with an automated mechanism to either throw up an alert or pause a container or quarantine a container or terminate a container. So that's kind of a very rich set of features powering the three pillars there.
Yeah. I would love to change course a little bit and ask about the relevance of observability today in cloud native application security. It gets a lot of attention now, and you make this connection between security and observability. How do you see that connection?
Yeah. So first, we are seeing those two spaces, which 2 or 3 years ago, they were pretty independent and disparate. But we see those two converging, security and observability, because the reason for that is the underlying solution to both solving the security problem and the observability problem is your ability to instrument everything that is happening in the system at a very fine-grained level, gather the data, and really make sense of the data, right? So that's really what you're doing, whether you're solving a security problem or you're solving an observability problem. So we see an incredible synergy between those two. And the other part is that there's also a relation in the sense the minute you start to provide extremely fine-grained security controls, it's very possible that some things may not work as desired for a developer. So troubleshooting becomes essential. And one of the primary reasons why developers try to work around security controls is that A, they're complex, or B, sometimes they just get in the way when something isn't working. More often than not, it could have been a security control that's preventing their microservice from talking to some other microservice. So bringing those two together, we feel like it puts the power in the developer's hands and it brings them into the equation. And it also ensures that there's better leverage for the data being collected. Because what you don't want to do is to have two different mechanisms to secure and drive observability, and just in terms of the software footprint that has to exist on the cluster. So we actually are leveraging Envoy and our Calico is a single agent that does both things. And certainly from a customer perspective, they're looking for solutions to both problems. From a single vendor.
So for those maybe not familiar, Envoy is a service mesh, correct? And how does it then work with Calico?
So Envoy is a very powerful open source project that came out of this company, Lyft. I would not quite characterize it as a service mesh, but you're right in it that it is definitely leveraged in service mesh to solve a class of problems. So what we did was, first, I think we feel like Envoy is an amazing project. And we've embraced it almost 5 years ago because we have so much respect for the project and the founders around that. And it ran at scale in production. And that's something we deeply value because that's common to Calico. We run at scale in production in some of the largest companies in the world and the largest public service providers in the world. And so we leverage, so that's mostly for the data plane at the application level. It gives you access to that. And that's why we felt like we could provide a single solution from applications down to the network and make it completely seamless and transparent to end users. And we took that, like everything else, we have an amazing set of engineers. We have driven innovations in that. We've figured out creative ways to deploy Envoy and to ensure that it is operationally easy to maintain. There is less tax and consumption on system resources. And architecturally, we've come up with a much more elegant way to deploy that. And what I mean by that is traditionally, Envoy in a lot of other solutions gets deployed as a sidecar. And we've got a lot of feedback from our customers. And we deal with some of the largest financial services companies on the planet. And, for both security reasons and maintenance operational reasons, and also resource consumption, they just didn't feel there was a good, elegant way to solve and deploy Envoy. So we went back to the drawing board and came up with a much better way to address it. And that's really the solution we rolled out as part of Calico Cloud.
So it's not a sidecar. What are the drawbacks of the sidecar?
Sidecar, so first of all, just from a deployment, it is extremely complex and very hard to manage operationally. So that's the first challenge a lot of our customers run into. The second is, just from a security perspective, there is an incredible reticence to use the sidecar model among a lot of, especially the larger security companies, so the very larger financial services companies. So they're very hesitant to use that. And the next and the last thing is just the resource consumption. And again, we deploy it as a daemon set on the node, and that's a lot more efficient than maybe rolling out a few hundred copies on a single node, right? So it just gives you the economies of scale and less resource consumption. Because when you're running applications at scale, the resource consumption matters a lot.
Interesting. So I think about then your technology architecture and how you run it in production. And I'm curious about the roles that people play that you're seeing manage Calico Cloud and managing Envoy. And traditional architectures had a security team and an application development team, which really dates back to your earliest days. And maybe we wouldn't think that way if things had been different back at Sun, but that's just the reality of it. And so how are you seeing these really different communities finding a place with each other? And how do the technologies play a role in that?
I'm going to generalize a little bit. We see two categories of companies. So there are the cloud-first companies. Most, if not all, their infrastructure is deployed in the cloud. They don't have any legacy applications. And for those companies, in terms of the personas, we refer to them as DevOps or Cloud Ops engineers. And this person is pretty much responsible for the end-to-end. And what I mean by that is they're responsible for getting these applications deployed. They're responsible for troubleshooting and managing them. They're responsible for security and compliance. And the challenge they have is that there's just way too much on their plate to do. I think the breadth of technologies that they have to manage is just staggering. It's just stunning how many technologies and tools they have to manage. So what they care about the most is that any tool is easy to use and easy to maintain. And for the most part, they love for it to be invisible. And that's one of the things we're very proud of in Calico. We always get feedback that it just works. It's invisible. And we take that design philosophy and criteria to heart, where we're trying to constantly simplify everything. Everything is stable, it runs at scale. And we're using a lot of automation behind the scenes, and we use a lot of machine learning behind the scenes to take all the heavy lifting out of the hands of these cloud ops engineers. The second category of companies are the large Global 2000 companies. And from a team and resources, they're very well staffed. They have quite a few teams. If anything, the problems on the other end of the spectrum, they have quite a few people, they have quite a few teams, and all of them need to be able to participate in security, in designing the security and managing the security. And there's quite a bit of tension between the teams, the dev teams, the security teams, the platform teams, the DevOps teams. And the way we resolve the tension is that we have designed a very elegant security architecture model that we refer to as security tiers, where we give different teams different levels of permission to participate in the design and the management of security and observability with the right level of permission, so that the developer, he or she, can actually set security permissions and rules, but we kind of fence it so that they don't do something that would bring down the entire enterprise. And the security team has the final say, and they have the tier, they control the tier that's the most powerful. So that's how we reconcile that. And from a troubleshooting all observability functionality to our dynamic service and threat graph, we actually make it available to the developers in a self-service model using our bag. And they love it. They love it. And so this kind of breaks the tension in a large Global 2000 company where everyone can participate both in security and observability. And that's turned out to be a very effective solution.
We have about 5 minutes left, and you mentioned machine learning, and that piques my interest. I'm curious about what you're developing behind the scenes and how you're seeing your development in context with observability and its future, and how you think of it in relation to machine learning, because there's a direct corollary between the two.
Yeah, no, you're right. Absolutely. And it really starts with, we are one of the leaders in eBPF. We've invested quite a bit, and we leverage that both for security observability. We probably have one of the best eBPF data planes there, but that.
Can you just explain for people who may not be familiar with eBPF?
Oh, Berkeley.
What it is?
Oh, sorry. It's the extended Berkeley packet filter. The 30-second pitch on that is what it enables you to do is you can actually, at the user level, author some scripts through which you can actually peek into the kernel and maybe in a very safe way look at data structures in the kernel and maybe even impact some of the data in the kernel. So, and that's never been done before. Anyone familiar who's worked on the Unix kernel, we've gone through 2 or 3 decades where if you're in the user space, you never ever got to peek into the kernel space except through system calls. And so that's why eBPF is a very exciting technology. And we were one of the early leaders in that. We made a big investment, but we didn't want to force the market to adopt it because it's pretty early. But the point is that, the data plane itself is a means to an end. And what we have done over the last few years is build some very powerful software that enables us to actually in real time get data about workloads, about how workloads are behaving at the process level, the file system access, the system calls, the network behavior. And through that, we're able to gather a lot of data. And so that's a little bit of a build-up to answer your question, Eric. So then the question is, the volume of data is just overwhelming. And so how do you make sense of that? Because what you're really looking for, given that the nature of security breaches is an unbounded problem, what we do then is we baseline normal behavior of a workload across all these dimensions. And then we're looking for any deviations from this behavior on these 4 vectors: the process, the file system, the system calls, and the network. And then we then use that as signals of indicators of compromise. And through that, we design our security strategy and we take some corrective actions, either to, maybe alert the user or pause a container or quarantine it or terminate it, So that's where a lot of our innovation and investment is going, and we're very, very excited about it. And we're in a very unique position because we actually control the data plane. Also, we're in a pretty unique position to be able to innovate on multiple fronts at the same time. And by the way, everything I've talked about is also true for observability. So all the data we're able to go mine gives us a tremendous advantage in being able to provide the right observability tools for users, either to troubleshoot their applications or to address some of the security challenges that they're seeing.
Do you use your own observability tools or do you use other technologies too?
No, we use our own tools for sure.
Well, thank you so much, Ratan, for taking the time to talk today. I really enjoyed the discussion. Wish you luck in this new year, and we look forward to talking soon.
Oh, thank you, Alex. It's been fun. I appreciate the opportunity.
Tigera, the inventor and maintainer of open source Calico, delivers Calico Cloud, the next generation cloud service for Kubernetes security and observability. Tigera and the new stack are under common control.
Thanks for listening. Subscribe on Simplecast to listen to more episodes on the New Stack makers. Create and share your favorite audiogram using our Simplecast player. For more articles and great stories, go to thenewstack.io.